Humbert here, and so today we're going to be talking about Unit 3 and our learning target number 3, which is talking about dividing monomials. So you want to think back to the rules of exponents that we started doing at the beginning of last week. And those rules of exponents are going to be kind of more applied into what we're doing today. So let's go ahead and take a look at some of those. So first of all, some of these we've already talked about. We've talked about multiplying like bases. When you multiply like bases, you're going to add the exponent. That's what we worked on the previous note sheet. Next, when you divide like bases, this is a new one. When you divide like bases, you want to subtract the exponents. So a to the 6 and divided by a to the 3, we can subtract those exponents. 6 minus 3 is 3. Okay, so that's our final answer for that one. All we're doing is subtracting those exponents. Next one, this one's a little different, okay? So whenever you see a negative exponent, so if you have a negative exponent, you need to flip where it's located. Okay, so to flip where it's located, I see that b to the negative fourth is negative on the bottom, so I need to flip it up first. Okay, next, a to the negative first on top needs to be flipped to the bottom. Okay, so if it's negative on top, then we're going to flip it to the top and so forth. So b to the negative fourth, we're going to flip to the top because it's negative on the bottom. A to the negative first is negative on top, so we're going to flip it to the bottom, and that's what's going to make it positive. Okay? Next, let's take a look at the other ones that we've already done just as a reminder, okay? So when you take a power of a power, you need to multiply exponents. And then anything to the 0 power is always going to equal 1. So that's just a review of what we're kind of doing today. Okay, so here's one thing that's really important. So remember with negative exponents that you're going to flip the location of just the variable with the negative exponent. Okay, so you're only flipping the thing with the negative exponent. If it has a coefficient involved, you're not going to flip the coefficient. You're just flipping the thing with the negative exponent. Okay, so just keep that in mind as we move forward. Okay, so let's just take a look at these. So right now, for number 1, I have 4ab over a. Well, think about it this way. When we did 2 divided by 2 and stuff like that, 2 divided by 2 is equal to 1. A over A is also equal to 1. So those A's are going to cancel out. So then we're left with 4b. Let's take a look at number 2. So for number 2, we have 4a to the negative 2. So now you're probably thinking, hey, Miss Humbert, this doesn't have a bottom. Okay? Well, remember, if something's just written, that's the same as it being on top. So what I'm doing is I'm creating a bottom so that I can maybe flip things. Okay? So now I know a to the negative first right here. Since that's negative on top, I want to flip that to my newly created bottom. So we have 4 on top, and then we're taking a to the negative 2, and we're flipping it to the bottom so that now it's 4 over a squared. Negative exponents always go on the bottom. Okay, let's take a look at this one. So I noticed that b to the negative 2 is negative on the bottom. So if it's negative on the bottom, it needs to pop up to the top. So I'm going to take that b to the negative 2 and I'm going to flip it up. So then I have 6a, and now my b to the 2 is going to come up. You could write that as over 1 if you want, but you don't have to. You don't need the bottom of the fraction anymore if the entire bottom disappears. Let's take a look at number 4. So for number 4, we have a to the negative 2 on the bottom, and so we're going to flip that to the top. Now, when it comes to that b to the negative 3, the only thing with the negative exponent is that b. I want to keep the 4 on top, and it's just the b that I'm going to flip to the bottom. So I get b to the 3, and then on top I'm going to put a squared. So that right there is your final answer. Okay, so let's take a look at this. So we talked about this a little bit on the last note sheet. So here are the things you need in order to have a simplified monomial. So first of all, each base can only appear once. We want to have only one a. Whatever exponent is fine, but we don't want to have a squared and then down the road a again. We want to combine those. We also don't want to have power of powers. All right, so we don't want to have a squared to the third power. We want to simplify those. We can do that by multiplying exponents. We also want all of our fractions to be in simplest form. Reduce all of your fractions. And this is the new one for this note sheet, and that's that there are no negative exponents. So we need to make sure we flip and get rid of all negative exponents. All right, let's go ahead and take a look at this in practice. So we're taking a look at this, number 5. So here's what I want you to do to start off with. So a to the 5th, that's the same as having 5 a's. So 1, 2, 3, 4, 5. Then as that b to the 8th, that's the same as having 8 b's. 1, 2, 3, 4, 5, 6, 7, 8, divided by a, and then there's 3 b's on the bottom. So what I want you to do is cancel out pairs. Okay, so there's a here, so those are going to cancel out. Then this b cancels this b cancels this b cancels this b. So now I'm going to count how many a's I have left. I have 1, 2, 3, 4. I have 4 a's left, so that's going to be a to the 4th. Now notice all of my leftovers are on top, so I'm going to write them on top. Then I have 1, 2, 3, 4, 5. I have 5 b's left on top, so that's b to the 5th. Now some of you might have noticed that these exponents were just subtracted. If you can see what I'm talking about and you want to do it that way, that's fine. This way is just a little bit simpler while we're getting going here. So taking a look at number 6, I have 3 x's on top and 4 y's on top, and then I have 2 x's on the bottom and 1 y. So now I'm going to go ahead and cancel out my pairs. So those cancel, cancel, cancel. So then left on top, I have x, and then I have 1, 2, 3 y's. So since I have 3 y's, it's y to the 3rd. So that right there is my final answer. Let's take a look at some more complicated ones. So now we're taking and we're raising things to powers for fractions. So what I want you to recall is that this coefficient of 2 has an exponent of 1, as does this coefficient of 3. So each of them have a power of 1. So when we multiply exponents, again, we multiply because we're taking a power of a power. Each of those exponents need to be multiplied by 4. 2 to the 1 times 4 is 4. P to the 2 times 4 is 8. 3 to the 1 times 4 is 4. So now I want to go ahead and simplify that out, okay? So first, 2 to the 4th, that's going to give me 16. And then I have p to the 8th. Okay, so p to the 8th is going to stay the same. And last but not least, we want to take 3 to the 4th. So that's 3 times 3 times 3. And that's going to give us 81. Okay, sorry, 3 times 3 times 3 times 3, 4 times. So this right there is your final answer. So don't leave it as 2 to the 4th. 2 to the 4th is the same as 2 times 2 times 2 times 2, and so forth. So now let's take a look at number 8. That 5 has an exponent of 1, as does that 6. So when we take that 2, we need to distribute it into every single exponent. So 5 to the 1 times 2 is 2. X to the 3 times 2 is 6. Y, remember there's a little exponent of 1 there. If there's no exponent, then the exponent is 1, and 1 times 2 is 2. 6 to the 1 times 2 is going to be 2. So let's simplify this out. 5 squared, that's not the same as 5 times 2. 5 squared is the same as 5 times 5, which is 25. And then we have x to the 6th, and we have y squared. Then beneath, we have 6 squared, which is the same as 6 times 6. So that's going to give us 36. Okay, so then this right here is our final answer. Let's keep moving forward. Okay, so now this one can get a little confusing. So I have 2 x's on top, and I have 2 x's on the bottom. Well, what I notice is that everything cancels out. Now, normally when students see that everything cancels out, they think that it is equal to 0, but it's actually equal to 1. When everything cancels out, it's equal to 1. Okay, and you could also look at it this way. If we were to subtract our exponents, like you do when you're dividing monomials, you get x to the 0 power, which is equal to 1. Let's go ahead and write out number 10. So we have x, and then that next one has 3 x's. So I'm going to write all of those out. Then on the bottom we have x to the 4th. So I'm going to write out all of those. So then we can cancel each of those out again. Since all of them cancel, it's going to be equal to 1. If everything cancels, it's always equal to 1. Next, let's take a look at these. So for number 11, I see that b to the negative 3 is negative on top, so I'm going to flip it to the bottom. I see that d to the negative 5 is negative on the bottom, so I need to flip it to the top. That c squared is going to stay on top. So c squared stays on top because it has a positive exponent on top, so it needs to stay there. That d to the negative 5, when I flip it up top, it's going to become positive. B to the negative third is going to flip to the bottom, and when I flip it to the bottom, it's going to become positive. So this right here is your answer for number 11. Let's take a look at number 12. So for number 12, first thing I want to do is I want to reduce this fraction. Now this can look really overwhelming, so I'm just going to take it piece by piece by piece. Well, negative 3 over 21. Both negative 3 and 21 are divisible by 3. Negative 3 divided by 3 is negative 1. 21 divided by 3 is 7. So now I've reduced that fraction. So I'm just going to keep working around, and I'm going to figure out any of my negative exponents. Well, this a to the negative fourth is negative on top, so I'm going to bring it on down to the bottom. This b to the seventh, positive on top. I'm going to keep it on top. Here, this a squared, positive on the bottom. I'm going to keep it on the bottom. B to the seventh, positive on the bottom. I'm going to keep it on the bottom. Then here I have c to the negative fifth, negative on the bottom. Flip it to the top to make it positive. Now let's go ahead and write out our letters so we can figure out what we need to cross off. We have 1, 2, 3, 4, 5, 6, 7 B's, 5 C's. Down below, 4 A's. Oops, and we have a negative 1 up here and a 7 here. And then I have 2 A's, and then I have 7 B's again. So now I want to go out and cross off what I can. Well, I have 1, 1, 2, 2. So I'm just crossing off any pairs. So I notice that all of my B's completely cancel out. So they cancel out to 1. None of my A's or C's cancel out because the C's are on the top and all the A's are on the bottom. So I have C times C times C times C. So I have 5 C's. So that's going to be C to the fifth. And on the bottom I have 7. And then I have 1, 2, 3, 4, 5, 6. I have 6 A's on the bottom. So that's going to be A to the sixth. So this right here is your final answer. If you don't want to write the negative 1, you don't have to. You could also have written your answer just like this as well. Okay? Next, let's take a look at number 13. It looks really scary, but I think we can do it. So we have negative 3 divided by 12. Negative 12. So first of all, those negatives are going to cancel out and it's going to become positive. Then I know that both 3 and 12 are divisible by 3. So I'm going to write that as 1 over 4. I just reduced that fraction. I see that q to the negative 2 is negative on top, so I'm going to flip it to the bottom and make it positive. Then we have r to the first, that's positive on top, so I'm going to keep it on top. S to the fourth, positive on top, so I'm going to keep it on top. Then I'm going to look to the bottom. Q to the first, positive on the bottom, keep it on the bottom. R to the negative 1, negative on the bottom, flip it to the top. S to the negative 5, negative on the bottom, flip it to the top. So now all of them are positive. So let's go ahead and let's write it out. So I see on the top I have this R, and then I have this R. So I have 2 R's, and then I have 1, 2, 3, 4 S's, and then 1, 2, 3, 4, 5 S's. Divided by 4, and then 2 Q's, and another Q. Well, none of those are going to cancel because there's no letter that's on the top or the bottom. So then on top, I end up with R squared. And then when I count up how many S's I have 9. So I have S to the 9th. Divided by 4, there's 3 Q's. So that's going to be Q to the 3. Now, let's do the same thing for number 14. So for number 14, you have 24 divided by negative 6. Well, 24 divided by 6 is the same as negative 4. And I'm just going to put that as over 1. So then here I notice that this x to the negative 2 is negative on top, so I'm going to flip it to the bottom and make it positive. Y to the fourth is positive on top, keep it on top. X to the negative 3, negative on the bottom, flip it to the top. Y to the negative 2, negative on the bottom, flip it to the top. Okay, Z to the negative 1, negative on the bottom, so I need to flip it to the top. So now the only thing I see that are on the top or the bottom are my x's. So I'm only going to write out, let's actually write all of our letters out for practice. So I have negative 4 and then I have 4 y's and 3 x's, 2 y's and z's, and then on the bottom I have 2 x's. So I can cancel those x's out. And then on the top I'm left with 4. I only have 1 x left. I have 6 y's left, so I have y to the 6th and 1 z. So that's going to conclude your note video today. Go ahead and we'll go ahead and skip this problem. We'll talk about it live in class tomorrow. So thanks for listening, and show me your completed note sheet except for this problem once you're done. Thanks for listening.